Hello students, today we are going to start with the chapter Thermodynamics. It is a branch of physical chemistry in which we can study about the energy change during any physical and chemical process. In other words, thermodynamics is a branch of physical chemistry which deals with the energy changes accompanying physical and chemical transformations. Some terminologies which are closely related to thermodynamics are as follows. First term is system. A system is defined as the specific portion of the universe on which the effect of certain properties such as temperature and pressure is to be studied. System is separated from rest of the universe by a definite boundary. You can see in the picture there is a beaker containing water, and inside the water a test tube along with the reaction mixture is submerged. So the test tube along with the reaction mixture forms the system, and the beaker along with water forms the surrounding. And both system and surrounding, they combine to form the universe. System and surrounding both are separated by actual or imaginary boundary. Second term is surroundings. The rest of the universe which is not a part of the system is called surroundings. System and surrounding are separated by real or imaginary boundaries. Let us continue. For example, when a chemical reaction is carried out, everything other than reaction mixture, that is test tube, along with the test tube is called surrounding. Types of system. This is the next subtopic under thermodynamics. So there are three types of systems: open system, closed system, and isolated system. Let us see what an open system says. A system which can exchange matter as well as energy with surroundings is called open system. For example, tea placed in an open cup. Second type of system is closed system. It is a system in which only exchange of energy takes place with the surrounding, and it is called a closed system. For example, tea placed in a cup covered with a plate. Third type is isolated system. A system which can exchange neither energy nor matter with the surroundings is called an isolated system. For example, tea kept in a thermos flask. Now, state of a system. The state of the surroundings can never be completely specified. So, the state of a system means the condition of the system which is described in terms of certain measurable properties such as temperature, pressure, and volume. If any of these properties of a system changes, it is said to be in a different state. That is, state of system changes. That is why these properties of the system are specified by the state functions or state variables. Hence, the next term to discuss is state function or state variables. These are measurable or macroscopic or bulk properties whose value depends upon the state of system and doesn't depend upon the path by which this state has been reached. A state function, for example, suppose we have to go to 5th floor of a building located at height h. Then h is a state function because its value depends only upon the location of the 5th floor and is independent of whether we go by stairs or by lift. State functions are very useful because change in their values depends only on the initial and final state of the system and not on how the change was carried out. Some examples of state functions are given as pressure, temperature, volume, amount of a substance, etc. Next topic to discuss is extensive and intensive properties. Let us take first the extensive properties. The property of a system whose value depends upon the amount of the substance or size of matter present in the system are called extensive properties. For example, mass, volume, surface area, internal energy, enthalpy, entropy, free energy, heat capacity, etc. The next term is intensive properties. These are the second category of thermodynamic properties, and their value are independent of the amount of the substance or size of matter present in the system. For example, temperature, pressure, viscosity, surface tension, dielectric constant, specific heat capacity, density, etc. That's all for today, students. We will continue in the next class.